Hey guys, Mr. Gron with the 8-8 challenge video. So a little bit of talk about extraneous solutions and then one really big problem. All right, so extraneous solutions is something I've talked about in a previous challenge video, and I'd mentioned that these are things that sometimes the way they're taught, they seem like just some random thing that there's no reason behind them. But I said, no, there's a very good reason that they're there and they're predictable and they follow a certain order, just like everything in math. And this is happens to be a particular type of extraneous solution that's very easy to visually represent. All right, so this is a problem that we did in the lesson, and actually it was 4x plus 12 to the 1/2 power, but I want this to just look a little bit more familiar. So I changed it to square root since it's the same thing. Now, when we solved this in class, of course, we squared both sides, and we got 4x plus 12 equals x squared, and then we, moved stuff to one side, factored it, and we got that the solutions were x equals 6 and then x equals -2. But we found out that x equals -2 doesn't work when we plug it back into this equation, and that makes it extraneous. Now, I want to explain why that happens in this particular one by looking at the graph of this. So this Desmos graph, this is the green part of the graph is the left side of the equation, 4x, square root of 4x plus 12, and then the purple is the right side of the equation that was just x, and where those two lines intersect, that is our solution of a positive 6. The x value from the solution is a positive 6 because it was x equals 6. We also got an x equals -2. And here's something that's interesting. If I take this graph of the positive square root of 4x plus 12 and I make it negative, and then I look at the intersection, that intersection is at x equals -2, and that was our extraneous solution. So here's why that happens. When we go back to that equation, notice I left a little extra room in front here, because I'm going to put something there in just a second. This represents the positive square root of 4x plus 12. And when I square that, I get 4x plus 12. But I also get that if I square the negative square root of 4x plus 12, because that squaring causes a negative times a negative to be a positive. And so this goes away, and it ends up becoming the same equation, even though it would have started differently. And that's exactly why this creeps in there and we get that problem. So really with any radical equation, any square root equation, if you graph it and you also graph the negative, or if you're given the negative, you graph both of them, the positive and the negative, you will find you could graphically figure out any real solutions and any extraneous solutions. All right, so let's take a look at one big problem. So this is a pre-calc problem where we have to solve the following. Now, we did some stuff that looks similar to this in class. However, I can see that if I start by squaring this side, that's all well and good. That's going to equal -3 minus 4x. It just cancels out the root. But squaring this side, this 1 out in front, and the plus, that kind of presents a little bit of a problem. That makes this a lot more complicated. Here's how what one of these looks like. Now, I'll get it started. If you want to pause at any point and try to continue it on your own and see if you can solve it, feel free. Or it might even be one where you just watch me solve it and then just try to solve it again on your own to see if you can do it and not make any algebra errors along the way. Okay, so when I square the right-hand side, it becomes 1 plus the square root of -2 minus 2x times another 1 plus the square root of -2 minus 2x. And it becomes kind of a big unwieldy foiling problem because I need to distribute that 1 into both and then the square root into both. And I can really treat that square root as its own thing. All right, on the left-hand side, I'm just going to make things into standard form. And now as I FOIL this out, I have 1 times 1, then 1 times the square root, then another, the square root times 1, I guess in this case. And then the square root times the square root, it cancels the square root, and so the only thing that's left is what's on the inside, -2 or -2 minus 2x. Okay, now I'm going to clean up the right-hand side. Oops, I should write this correctly. So we've got, I'll move that -2x in front. The 1 minus 2 ends up being a -1, and then there are 2 square roots, so plus 2 roots of -2 minus 2x. Okay, now this actually looks a little more like something that we've done in class. It's a little bit bigger, but it should be fairly straightforward at this point, if any of these could be considered fairly straightforward, that is. So we'll isolate the radical. That will be -2x minus 2 equals, this stuff cancels out and we get 2 root -2 minus 2x. Now for this one, because everything is divisible by 2 and I've got this coefficient of 2 in front of the square root, I'm going to divide that out because it's not going to create any fractions over on the other side. So that becomes -x minus 1 equals the square root of -2 minus 2x. And now I can basically repeat that process that I started with by squaring both sides. So throw some parentheses around there. Oop, that's a terrible 2. Okay, so then on my left-hand side, this becomes -x minus 1 times another -x minus 1. And now the right side is a little bit nicer because the root just cancels out. All right, we've got a little more foiling to do. And that is going to be x squared plus x plus x plus 1. I'm going to rearrange this into standard form, -2x minus 2. Okay, combine some like terms. We get x squared plus 2x plus 1 equals -2x minus 2. Boy, this is a lot of steps. Now it's a quadratic, so I'm going to set one side equal to 0 by bringing the 2x and the 2 to the other side. So the left side is now x squared plus 4x plus 3. Everything canceled out here, so it equals 0. Now I've got a factorable quadratic. We're almost there. X plus 3, x plus 1 equals 0. So I potentially have 2 solutions of -3 and -1. Now is it going to be both of them good solutions, one good and one extraneous? I don't know. Let's find out. Now this one is such a big problem. I actually put the equation down here as a reminder of what it was so I could look at it real quick. Okay, so we'll check the -3 first. So that was the square root of -3 minus 4 times -3 is equal to 1 plus the square root of -2 minus 2 times -3. Oh, I hope I didn't screw that up at this point. Yeah, that looks good. Okay, so -3 minus 4 times -3, that's -3 plus 12, which is 9. And -2 minus 2 times -3 is -2 plus 6, which is the square root of 4. And so the square root of 9 is 3, and the square root of 4 is 2. So 3, I think, does equal 1 plus 2, so that one's good. Now let's check the -1. So that would be negative 3 minus 4 times negative 1 is equal to 1 plus negative 2 minus 2 times negative 1, and that's going to be negative 3 plus 4 is 1, and 1 plus negative 2 plus 2 is 0, so 1 equals 1 plus 0. I think that also checks out, and so we have two good solutions to this equation, which, look at that, I ended right above it. So the solutions to that, our two good solutions, are negative 3 and negative 1.